So as we are now moved online to digital learning and we are seeing the spread of the coronavirus become more and more rampant, I've kept on thinking back to this is the perfect time to show our students how science, and for me specifically chemistry, can be related back to the real world and something that they can relate it to that's going on right now. And so as I'm looking at this and we're hearing that washing our hands is so important, and I thought this would be a great time to send a video out to my students, especially my AP kids, about why washing your hands is so important. And we can relate it back to some of the chemistry concepts that we have discussed in our AP chemistry class. And for others, it can be just a review on chemistry whenever they had it. But we can kind of look at a couple basic principles that we've talked about in class to help us understand why washing our hands is so important. And one thing I kind of ran across as I was looking through some different sources and websites, and we keep hearing COVID-19 versus the coronavirus, and I was like, well, what's the difference? Are they the same thing? What are they? And so I kind of ran across it, and the COVID-19 is the respiratory illness caused by the coronavirus that we are seeing spread. And then this coronavirus that we are seeing has been given the name SARS coronavirus-2. And so just a little side note, but just looking at the chemistry behind it and just kind of reviewing why it's important to wash your hands and, just helping students relate what we're learning in class back to the real world. And so students in my class will be more familiar with these key points, but if you've taken a chemistry class, especially AP chemistry, then these will be familiar to you. But one thing that we discussed in my class, especially when we were talking about the molecular structure. So how do we draw Lewis structures? Why is it important that we know the structure of our molecules? And that's because structure is related to function. How something is structured, or the structure of an object or a tool, or in our case molecules, the structure is directly related to how it functions. And so the more we can learn about the structure of the coronavirus, the more we can understand how it functions, and the more we know about how it functions, the more we can implement strategies to defend ourselves against it, but also helping the pharmaceutical community come up with different treatments and ways to fight the virus. And then the second point we'll kind of discuss is like dissolves like. And this goes back to polar dissolves polar, non-polar dissolves non-polar. And again, we have to look back to the structure of our molecules to understand polar versus non-polar. And so when we look structure being related to function, we talk about the water molecule and how the water molecule is bent. And so we can see here the hydrogens are being pushed down. It's not shown in this diagram, but there's two lone pair of electrons here above oxygen, giving them 4 electron groups, making that electron geometry tetrahedral, and then making the molecular geometry bent. And because water is bent, there's a lot of implications to that, mainly making water a polar molecule, meaning that we have our different regions. So the regions around hydrogen are partially positive, denoted by this symbol here, and then the regions around oxygen are partially negative. And so because it is bent, we have a dipole that forms, and a dipole is just two regions of opposite charge, and we have this attraction form. And so you see it's represented by a dotted line. That dotted line, that attraction, that's an intermolecular force, as you'll remember, and that's hydrogen bonding. It's not a bond because electrons have not been shared or transferred between these water molecules, but it is a very strong attraction. So the structure of water directly relates to these hydrogen bonds forming. And then another thing that will be important to understand is kind of the structure, phospholipids, the structure related to its function. And so you can kind of see, and this is getting to some into biology, but if we look here, we have the head of the phospholipid, and then we have our tail. And that's kind of the most important distinction to make And we have our fatty acid chains, and my students, you should remember that we have a bunch of carbons and hydrogens here on our chains, and those are all nonpolar. So that region of this phospholipid is nonpolar. And then we have our region up here. We see different electronegativities. You see polar here. We can see some polar regions up here. And so the head is primarily, we say, is polar. It's hydrophilic. It's attracted to water. And then we look at this fatty acid chain, or this nonpolar region being hydrophobic. And so meaning it doesn't interact with water. And that goes back to like dissolves like, right? Water is polar, has that dipole, whereas these regions of the phospholipid are nonpolar. And so we can see these chains, these nonpolar tails, they're not attracted there. And that'll be very important as we understand the coronavirus and how washing our hands is so important. And here we see kind of a rendering of the coronavirus, and you see different proteins around it. We won't get into what, their function, but the main thing to look at is this lipid membrane. And so we look back to our structure. We think back to that phospholipid. That was just an example. But here we have our lipid membrane, and that lipid membrane is going around this virus. And so if we can break down that lipid membrane, we can essentially break down the coronavirus and essentially get rid of it. And so when we look at the structure of a lipid, just basic structure, you see that we have the hydrophilic head, the hydrophobic tails, and so water will interact with the heads, but water will not interact with the tails. And so what we can do, we have a lot of water in our body, but what this does, this lipid layer that we see here, it protects the virus from the water in our body, and so it allows it to enter our body and not mix with the water and then break apart. And so it's important that we have something that's nonpolar as well that can break down this lipid bilayer. And so when we look at soap really quick, the structure of soap, we're not going to get too much into the exact structure of soap. If you want, you can kind of pause this. This is a really cool just infographic from Chemical and Engineering News, but you can look at the main thing to focus on here is we have a hydrophilic region and a hydrophobic. We have a polar region and a non-polar region to soap. And so that's important because when we mix soap and water, the hydrophilic part can mix with the water, but then the hydrophobic part can mix with the oils and the grease that's on our body and ultimately the coronavirus that's on our body, and it can help break that down. So soap is very, very important in washing ourselves. So water is not, just using water is not going to do it. Again, when you have this virus here, you have that bilayer, that lipid membrane. And if that lipid membrane is not broken down, then we're not breaking apart the coronavirus here. And so then we're not getting rid of it. And so when we look at what's going on here, we can take the coronavirus and you can see that lipid membrane. What happens here? So we have our soap molecules. You have the hydrophilic head that interacts with the water. You have the hydrophobic tail. And so we remember like dissolves like. And so our soap can dissolve in water because this hydrophilic region, this polar region, interacts with the polar water. And then this non-polar region, we see here, once these soap molecules can wedge themselves into the lipid membrane, that because the lipid membrane is nonpolar and the tails here are nonpolar, it can then break that lipid membrane apart, essentially breaking apart the coronavirus. And so when we look at washing our hands is very important, not just with water, but adding in the soap. So because the soap can break this down and get rid of it. And then with running water, we're just washing it down the drain, but the soap is already broken apart. And so this kind of helps us understand how something that's very easy and simple to do can go a long way in protecting us from the coronavirus and helping us kind of get rid of it and stay healthy.